Next, see what we have. We say cosine is actually a odd function. Now we're going to prove you why we say that. Okay, and then remember we got this function of t, which equal to sine of x. Now the way to check, you just make t negative, so which will be something like the sine negative t, and the answer to this, it will give you negative sine of t. So for that reason, we will say this is an odd function. Okay, and this is the first condition that we may have. Okay, and we do have another condition, which is if. Okay, so now this is what we say symmetrical at origin, and then the representation to this, the reason why we say this is a symmetrical at origin, we're going to draw for you. This is what we're going to draw, similar to the cosine integral. So this is a sine integral of t equal to 0. So we're going to represent this so that for you to see what we're trying to say and what does it mean, symmetrical origin. Now let's see what is symmetrical origin. What does it mean? Where's the origin? This is where we have the origin. It's actually at 0. That's where we have the origin. And why we say this is symmetrical? Look, I'm going just to draw it so that you can see. You see the yellow line, the yellow curve. And then let's go with another color. Let me just keep it as this. So let's go with another color. Now this side here on the negative, remember this is where we have negative here and another negative, and here positive and another positive here. So what we say symmetric is because when we make t equal to negative t, we get negative sine of t. So because of that, that's why we say this is symmetrical at origin. And also even consider representation. This is what we call symmetric. This is where we have our origin. So this is where we have our origin. Okay, so this is where we have our origin. So for that reason, we say this is symmetric at origin. Okay.